Okay, so first of all, hello, my name is Kirill, and I'm working for some years as engineers. Last 3 years I'm working in Bolt. And today, as you see, the topic of this presentation will be just a short story how in Bolt we migrated our backend into Kubernetes, because previously we ran everything on EC2. But before we start with fancy slides and some graphs, quick quiz. Can please everyone who already run Kubernetes in production raise their hand? Okay, so nothing to tell. Everyone have Kubernetes, so I hope it will remind you about this time when you migrated and will not make you struggle a lot. And first of all, some Bolt numbers. So no surprise for everyone that Bolts operate in many cities, many countries, a lot of people involved into development of all these fancy products. About these fancy products, maybe most of you already tested or used it, is rides products, rentals, drive, delivery, and market. So why I'm telling it on technical presentation about all this number was quite boring for someone, is that because I want to tell how we're doing it in Bolt, because a lot of customers, a lot of employees, high demand on new products. And this is our engineering department. Our engineering department, or foundation, is split into different layers, kind of a pyramid. In the bottom of these layers, infrastructure layer, where SRE department continuously working on providing new infrastructure, new products, running a lot of fancy stuff and make it work 24/7. Next layer in our engineering department is framework layer. So Pine team, our lovely colleagues who develop framework which used across all our services. So by default, we have some libraries which include service discovery, metrics, and any other useful instruments just to let developers focus only on business feature. And of course, development department. So our two departments, Pant and S3, support hundreds of developers. These developers split between different teams. And we continuously working in collaborations, bringing new ideas to make things work better and without the issues. A bit more about SRE department, how we split responsibilities in our SRE team. So one of the team inside our SRE is DBRE, Database Reliability Engineers. These folks are working on everything what relates to backend databases. We use MySQL, TitaniumDB, interesting products. It's not loading and loading. Next team, SRE Cloud. Well, quite easy to guess that SRE Cloud responsible for cloud management. So I'm as average SRE engineers don't really work much with our AWS infrastructure, at least in terms of permissions, IAMs, and so on. But these guys do. Next important team, SRE Data team. So this team is responsible for everything what relates to stateful infrastructure for our backend services. They're responsible for Kafkas, Redises, and a lot of interesting things. By the way, next presentation, don't skip, will be from Nikolai, who working in this team. And last team, SRE Platform. This is where I'm working for some years, and we are responsible for providing all infrastructure to make Bolt backend services works. And back to the topic of presentation, in 2022, we had such numbers, around 400 EC2, where we ran around more than 2,000 microservices, quite a lot. So maintenance of such big amount of instances quite difficult, a lot of maintenance overhead. And if you are telling about this maintenance overhead, I would like to start about first problem, provisioning new capacity. In case if you need to provision new capacity just on EC2, we had just, too early. We had just engineer who created instances with Terraform, provisioned all companies with Ansible. It took some time, had some problems, and so on. Next problem is proper capacity calculation. Well, imagine that, again, you have hundreds of hosts. There is dozens and hundreds and thousands Docker containers running on this host, and you can't be sure all the time that you not over-provision resources, because it affects bill, affects how company grows and how business running. So a bad thing for us. And somewhere in the background, always some engineers was rescheduling services from one issue to another issue to scaling instance types. A lot of work required to support it. Another problem for us is the releasing of and scaling of microservices. So in Bolt, we have our own CI/CD tooling, which is responsible for delivery Docker containers on EC2 in the past, now in Kubernetes. And previously, all the time, when someone releasing new microservices want to scale some services on more hosts, it was require participation of SRE engineer to assign some EC2 tags, to calculate how many hosts we need, which instances type could be better in this or another case. So a bit of math tasks. Next problem, I suppose everyone also faced with this in the past, is about maintenance and keeping system updates. Because, for example, we hope that we are secure enough, at least we didn't have a big leakage, so we're keeping up to the latest operation version system, latest version of some system components. Of course, it means that one thing if you already have the instances, another thing if you're preparing some new feature, release it on all these hosts, and again spending this time. And related topic to previous one is about poor automation opportunities. So maybe someone already had experience with Bash and other scripting in production that, as you know, like in time manner, yes, first it's resolve some tasks, but in the future it's not supportable at all, especially when people changing, company grows, and so on. A lot of words, but if to rephrase these things shortly, some nice graphs. So we wish to improve automation, reduce manual work, improve our resource utilization, and as a result, reduced cost for our infrastructure. So to have so many goals is great, but in what way to go? Because we understood, yes, we have Docker containers, we have EC2, and now we need to migrate on some orchestrator system. So looks like that the choice was quite obvious. We have Kubernetes, everyone works with Kubernetes, but inside our company, we still have some conversation about should we go in Kubernetes or some other systems, which I don't want to mention right now if you think about it, but they still existed. And based on it, we just made some criteria to understand what will be the right things for future of infrastructure. And the first criteria for us was that it should be a well-known product on the market. Why it's important? Because it reduces your time, what you're spending on looking for new information, looking for, I don't know, some Stack Overflow questions and so on. And also it potentially reduces the problem during new hirings. Because again, if business is growing, you're looking for new people, and not so many people on the market who knows about how to work with some voodoo orchestrator. Next criteria for us was not to bring extra maintenance. Hopefully we have a lot of challenges in Bolt, and we didn't want to spend our time on some investigating of some new approaches how infrastructure works. And last thing, but not least, of course, it should be suitable with our current infrastructure. So we had in the past everything in AWS, we have now everything in AWS, and we wish to keep the same approach right now, to not to migrate to new cloud or whatever. So, not a big surprise that we decided to use AWS EKS product because it perfectly fit into our infrastructure ecosystem. Managed control plane save you a lot of time on maintenance, of course. And Kubernetes API, well-known product on the market, so everyone read or used or at least touched it somehow locally. So product was chosen and start to implement, but there was few things which was the most important things for our departments. First thing, how to achieve migration without service interruption for end clients. Just for understanding, we have more than million requests per second in our front-end layers. And any problems means that customers will not get their food, they will not be able to order a taxi, and I suppose no one wants to face with this. And next thing is about how to perform migration without blocking team to develop a new feature, because business want to run fast, want to be compatible with other companies, and we just can't lose the time by blocking deployments. But for us, it was easy to resolve because as part of preparation to migration to Kubernetes, we split our infrastructure to separate layers. So first layer with EC2, what I mentioned, we had 100 of hosts where Docker containers was running. Next layer, we had a huge migration to Envoy, so they're running separately and proxying requests from end customers to our backend service mesh, and inside service mesh provide communication between microservices. etct live his own life somewhere separately. We use it for service discovery, so service left information about themselves in this system, and based on this information, we build configuration for Envoy. And no surprises emoji. I'm not a huge fan of them, but this is how we call our internal CI/CD tooling. It's called Unicorn Builder, and of course, it's responsible for provisioning all the systems and all the services to some compute. So with such setup, we just had to replace one layer with EC2 to another layer with Kubernetes. So sounds quite easy, but asking me, was this migration issue for us? I will answer that yes, it was quite easy. But of course, a million of nuances which forced me to say that it was relatively easy. As I mentioned, layers approach reduced a lot of time for us and make our life more easier and happier. We're just talking about replacing compute layer. Next one, very cool things is AWS EKS CNI plugin. Thanks AWS for development of it, because with this, we just got easily connectivity between pods and services running on EC2, because we had the same IP space between old and new infrastructure. So we just left to move forward. Sounds smooth. But next questions. Did we make any mistakes? Of course we did. We are not hiding it. We prefer to telling about it honestly to avoid it in the future and don't let people to make such mistakes again. About mistakes, what we did, I split it into multiple categories. One of the first is that a lot of people in our company and our department was thinking that it's just a tool. So you have Kubernetes, you will migrate on it, and everything will be work smoothly, but not. It was require a lot of activities to make it work efficiently, how we want, to avoid any failures. So don't underestimate this moment and make a good planning. Next set of the problem that it's a new technology. Well, I'm not meaning release date by itself, but when you're bringing some new technologies in such a big company where a lot of people working on the product, not everyone familiar with this. They heard it, but they're not worked with this, and this is even not their areas. For example, a lot of developers previously had EC2 where they deployed their services. They know they have operation system metrics like CPU RAM utilization and could track it. But with Kubernetes, we shift the mind that, okay, you have pods, you have to check how many requests, resources you need for deployments. Of course, it was also a lot of problems in planning because you don't know what you don't know. We was trying to run product in different ways, faced with some issues, roll back it, and improve our planning again to reduce stress from engineers and make everything in planning mode. Next set of problem is expectation. From both perspective, I can say that it is super important to keep scope as minimal as possible. Because in Bolt, for example, we combine some activities together with migration to Kubernetes, and it slowed down the migration on it. For example, we had all resources in one AWS account, but we decided we're strong and we can run Kubernetes in new AWS account, and then struggle and fighting a lot with permissions between different entities in AWS, so it was a struggle. And next thing is availability. So how it was for us? We created some Kubernetes cluster, somehow started to migrate on it, but in one day, someone accidentally deleted coordinates from the cluster, and we're like, oh, okay, we have a problem. So since that, we running all the services in 2 Kubernetes clusters. So that is why I mentioned about availability, that if you are running a new platform from one high availability system, make sure then even POC of the system is also satisfy your high availability something numbers. And next, with all these mistakes, want to tell a bit more about timeline, because of course it took some time. Maybe it will be interesting for someone who planning the migration. First, we started in 2021, planning sessions. Then obviously we prepare some POC, see that it works. Wow, we can continue. After that, for a year, we focused with other teams on engineering activities to make everything works, and migrated with dual setup. But I will let a bit more about each of the stages. So first one, this is a picture of our Jira. I suppose it's not confidential information, but it is what it is. Yeah, this is how we try to plan activities with other teams. After that, we're starting to work on POC, and this is a real screenshot. I keep it close to my heart, because it was the moment when we finally saw these letters not started. So first Bolt backend services was running in Kubernetes in test mode. And once we verified that, okay, we're ready, a lot of activities was done. And I will tell a bit of them just to show what stack we use, but this is not the all things what we did. So we was working on adoption of AWS stack, VPC configurations, IAMs, accesses, a lot of interesting things. Next one is to adopt our Terraform code base. So in the past, we also used Terraform for provisioning of everything. But anyway, we need to reuse some approaches what other team had in the past, because we had somewhere in Kubernetes cluster as well. Together with this, we started to use Terragrant, because as I mentioned, we have few clusters in live, and they have same configuration. Thanks to Terragrant for giving us this opportunity. Working on adoption of Flux for our needs. So from SRE side, we install all the companies what require for working the clusters with Flux. Next is Docker, obviously, because when we used EC2, we had a lot of self-written tooling, which needs for us and very important for visibility and observability, and that is why we also migrate this tooling to Kubernetes. Next one is about logging and monitoring, but from developer's perspective, we use Vector for logging system, Grafana, of course, and a lot of products around monitoring to keep the same level of experience. Because, for example, during migration, from developer perspective, you don't see a big difference between logs. So you have same messages from EC2, and you have the same messages from Kubernetes. Another thing, Carpenter. Yes, we use Carpenter in production. It works well. So Carpenter is responsible for provisioning all the compute, scaling instances, and so on. And our fantastic emoji with unicorn. So a lot of time was spending by our teams just to learn how to work with Kubernetes API, because we don't use some Some product solution we use our own. So it was a long way to adopt it, to work with Kubernetes. So a lot of things was done. And after that, when we did everything, we got the dual setup. What I meaning by saying these words? So all the services was running on EC2, and we started service by service, run it in Kubernetes environment. And we get situations that all the traffic comes into old backend infrastructure on EC2 and to the new infrastructure in Kubernetes. So teams was checked that services in Kubernetes works, no issues, no effect on metrics, and then we started to downscale the service on EC2. So this is our code from Ansible that we finally start to remove inventories. Yes, don't blame me, we use static inventories for our production. And this is our new feature with Kubernetes and a bit numbers. And now, if asking next question, was this migration success for us? Well, let me share a bit numbers first and let's collect information to understand was it good or bad experience for the Bolt. So I mentioned about one of the problems that we had issues with providing new capacity for microservices. At the time, what we spent on provisioning new resources decreased from 30 to 1 minute. And what is most important is doing automatically. SRE engineers are working on other activities and even don't thinking about it at all. So it's great, and thanks Carpenter for it. About next problem, releasing microservices. So as I mentioned, we involved SRE engineers to release and scale microservices, and the amount of incoming requests which was made through Jira Service Desk was decreased to 0. Obviously, because we revision the whole approach how we provision microservices in the Bolt. So hey, about automation. So as I mentioned, we wish to have some way to automate our internal infrastructure processes. And telling about it, I can say that we already made some automation products related to automation. And some of you products will be on the slide. First product is alerting. We prepare some advanced alerting for microservices. And if something happening with spot state, like OM killer or is spot is not ready, something relates to it, service owner who is responsible for these microservices get alert directly to it. And they have a great visibility if something went wrong after release or need more resources, for example. Next one is cost tracking. Again, in the past, we just has this pool of EC2, and it was difficult to understand which team and how much money these teams are spent. But with this product, we now understand that this team spends this amount of money, this amount of money, and as backend for this product, we use KubeCost, which is installed in our clusters. And the next one was related just to monitoring, because in the past we have quite interesting solution for discovery of metrics and points for microservices. And we get rid of all solutions, which was legacy, struggles in maintenance, and replace it with something new and automatic. So great success. And last numbers will be about resource utilization. Amount of EC2 what we had in our AWS account was increased from 400 up to 2,000. So it sounds quite strange because we wish to optimize it. But if to check next number about how much we saved real resources, we reduced the amount of provisioned CPUs from almost 9 to 7,000. And we reduced the amount of provisioned memory in 2 times. So just imagine how much our cost was affected on the infrastructure. And we also think it was a great success. And asking now, was it successful for Bolt? Well, last 6 months we fully operate in EKS. But to be honest, we migrated into Kubernetes almost all our backend services a year ago, and had just few edge cases which require additional development and tooling for migrate of them. But this 6 months is a honest number. We forgot about EC2 since that. And we are not talking about just some static cluster where we have some workload for increasing, for example, amount of pods for last year across our production cluster was increased from 20 to 30,000. So we are grow, and with all of this, we still don't have any issues with development, maintenance, backend infrastructure in Kubernetes cluster. So yes, I may say that migration was successful for both. We are so happy. Hooray. Thanks everyone for listening. So if you have any questions, feel free to ask.
Thank you.
Yay, first question. Oh.
Hi there. First of all, congratulations on this migration. It seems like the results are well worth it. I have questions about some unmentioned topics that you didn't cover, namely resource provisioning. Kubernetes, if you give a lot of control to the application or engineering teams, they get to define what they want to, what are the resource requests and limits that they want to run things at. How did you control for that? Because if you don't give like certain guidelines, it gets out of hand. People might not necessarily have a good, guidance on how to, provision their things. They might think that they request one core for their simple app, whereas if you monitor the actual usage, it's much slower. It's, smaller than 50 milli CPUs.
A good question. So, well, the thing is that I'm as SRE engineer and we don't touch so much CI/CD system, but I can answer on this question. So, we have few techniques how we resolve this problem. First one is our internal CI/CD system. From developer's perspective, if some service owner want to increase amount of resources and request it for their deployments, they don't have opportunity to put numbers like 10 cores, 1 core, whatever. They have some predefined templates, like we called it t-shirt sizes. So for example, you have template provide 0.1 GPU and 256 megabytes of RAM. Another thing what we are doing to cover this aspect is alerting system. So how we resolve it? We know information how many requests had a service. We also monitor how it really utilize. And if some services have too many resources, developers start to get alerts in their channels like, hey, you spent our money, please go and reduce it immediately. And it will keep spamming until they will change it. And this approach works more or less. So I don't have it here, but if someone already worked with Carpenter, there is nice graph that requested and how much utilized. And our graphs looks pretty okay. So what was requested that we utilize from this perspective.
I do have a follow-up as well. You mentioned Carpenter. I don't know exactly but I've read the documentation. I know what it does. Do you guys use it, or do you have VPAs or HPAs in use?
VPA is a good point. So you definitely read the documentation. So no, because of this, VPA out of the scope for us right now, everything left to HPA. So we use it together. So each service what running has configured HPA for it. And of course, we have enabling consolidation. So consolidation mechanism what recalculate how many capacity need and provision new nodes. So it works, again, quite well. Because hopefully, all the struggles about stateful is on these guys who are sitting here, and we are responsible only for stateless, so VPA is, we can do it, but it's not so important for us. We are working only with HPA.
Okay.
That's all.
Thank you. Any last questions? Okay.
No. We work together. Why are you doing it? You can do it in the office.
Thank you. What was the solution you don't want to mention?
Nomad. Of course, you wasn't aware about it, but yes, we were thinking between Nomad and Kubernetes. And hopefully so some team was pushed for one solution, some team pushed for another solution. And our team one. We use Kubernetes now.
Okay. Yeah. I have understanding or insight. Like Bolt was quite late adopter of Kubernetes, or where you position yourself?
Sorry.
But okay, the point is like the advantage of the companies who like get really invested in one point of technology, and then they get stuck into it, and they and do you think it's worth skipping like the part of technology? I'm not going to EC2 or hold this Docker part. I'm jumping straight into Kubernetes or like from bare metal.
We had a long way in Bolt. We have some variants of hosting infrastructure. We migrate something on EC2. And just in some beginning of time, how it's happening in big companies. For example, some people invest one approach. This approach works for years, but demand works, workload works, and teams not able to support these solutions anymore. So we just was forced ourselves to invent new solutions. Because anyway, we are not telling that Kubernetes is the last stage in our development. Maybe tomorrow we'll start to invest something else. Maybe we'll prepare our own orchestrator, but I don't want to do it because we have Kubernetes right now. But we'll see how it will go.
Yeah. Thank you.
Yeah, thank you so much. Oh, wow, present for me.